In this video, we're going to use vectors to determine which spring is longer in length. So you've got spring 1 on the left-hand side and spring 2 on the right-hand side. Spring 1 will have 3 turns, meaning 1 turn and then 2 turns and then 3 turns. So it will have 3 turns, and it will have a radius of 7. So it has a radius of 7, and the height here is 4. Let's say 4 centimeters. And spring 2 will have a height of 3 and a radius of 4. It will be shorter in radius, and it will have 5 turns. So 1, 2, 3, 4, 5 turns. It will have 5 turns. So the first step is to set up the position vector for both springs. But let's just look at this spring here. So in your mind, picture this. This is your y-axis. This is your x-axis. And if you picture this, we've seen this many times. This thing here will give you the movement of the particle that will travel around in circles of radius 1. We've seen this many times. And this will incorporate the height. Remember, this is your z component. So we want to set up in such a way that after 4 seconds, it would have risen by 4, let's say 4 centimeters. So let's ignore this z direction for the time being and concentrate on this. So in your mind, when you picture this, you should picture this: a circle traveling around in a particle traveling around in circles of radius 1. But then here we want a radius of 7. So stick a 7 in here. So this thing here will then give you a particle moving around in circles of radius 7. But here's the thing. The hard part is in deciding the coefficient in front of the t and the coefficient in front of the t, because as it stands, if you have, let's say, cos t, it will give you this. It will give you 2 pi. So after one revolution would be 2 pi, roughly 6 seconds. But the thing is, we want to create it in such a way that when t, well, we want to do it like this. So after 4 seconds, it would have risen by 4. But here, if you just leave it as cos t, one cycle will be roughly 6 seconds. We want it so that we will have 3 cycles in 4 seconds. We want to have it, well, the point I'm trying to make here is that we need to determine the coefficient. We need to stick something in front of this t here. We need to stick something in front of the t. If you consider this, if you consider cos, well, we know cos t will give us a period of 2 pi. But if you consider cos 2 pi t, then you're going to get a graph looking like this. So cos, a graph looking something like this. So this will be 1. And remember, if you stick 2 pi in front of this, you're going to have a graph looking like this: 2, 3, 4. You're going to have a graph looking like this. But the thing is, we want it so that we will have 3 cycles in 4 seconds. So after 4 seconds, we want to have it so that we will have 3 cycles: 1, 2, 3. We want 3 cycles. But if you look at cos 2 pi t, it's giving us 4 cycles: 1, 2, 3, 4. We don't want 4 cycles. We want 3 cycles. So we want to somehow stick the we need to determine this coefficient here and here in such a way that it will give us a period of, well, let's get this whole length here, which is 4, and then cut up into 3 equal pieces. So from here to here, it will be 4 over 3. You see, at the moment, we've got 4 cycles. We don't want 4 cycles in 4 seconds. We want 3 cycles in 4 seconds. So as it turns out, we want to determine the coefficient. We want to determine this coefficient here and here in such a way that it will give us a period of 4/3. Okay, I will continue in the next video.